help find the probability of an event related to a repeated experiment. Think about this question during the lesson. Sadie has one ticket left at the school fair, and she hasn't yet won a prize. She decides between two games. Which game should she play? Let's think about how we calculate probability. Does having more possible outcomes make it more likely or less likely that Sadie will win? For our first step, let's focus on the game Flip to Win. We can use a table to determine the probability of winning a prize playing Flip to Win. The first flip will be either heads or tails. The second flip will also be either heads or tails. So there are 4 possible outcomes, and there's one favorable outcome, 2 heads. What is the probability of winning a game of Flip to Win?
Select your answer.
Divide the number of favorable outcomes by the number of possible outcomes. The probability of 2 heads is 1/4, or 25%. Now, let's use a second table to determine the probability of winning a prize playing Spin to Win. Spinning the spinner has 3 possible outcomes: yellow, blue, and green. Our table shows each of the 9 outcomes of this compound event. There are 3 favorable outcomes, meaning there are 3 ways to win a prize playing Spin to Win. To find the probability of winning the game, divide the number of favorable outcomes by the total number of possible outcomes. The probability is 3/9, or about 33%. Now we're ready to compare the probabilities of winning each game. The probability of winning a prize at Flip to Win is 25%, while the probability of winning a prize at Spin to Win is about 33%. Sadie is more likely to win a prize playing Spin to Win, so she should use her last ticket to play this game. Now you know how a probability model, like a table, can help you find the probability of a compound event.
The designer of Spin to Win replaces the 3-section spinner with a 5-section spinner, as shown. Which game is Sadie more likely to win now?
Using the 5-section spinner, the probability of winning a prize is blank over 25 or blank %. Sadie is more likely to win playing blank to win. Now that the game has switched, each time she still has to get the same color twice, but each time she spins, she has there's 5 different colors this time instead of 3. So she has 5 favorable outcomes. So 5 will become that numerator, and there's 25 possible outcomes because each color she's spinning 5 times and could get the possibility of each color. So that's how you get the 25. So now, to find the percent, all you have to do if using a calculator is 5 divided by 25, and that will give you your percentage. In this case would be 0.2, or you could have written it as 20% as well. So Sadie is more likely now to win the Flip to Win instead of the Spin it to Win. So let me put flip.
Pilar and her family lost their pirinola, so they are playing Tomatodo with a homemade spinner. Part A. How many times do you predict that the spinner will land on Tomatodo in 300 spins?
The theoretical probability of the spinner landing on Tomatodo is 1/6. Here's Toma. And it shows you as a decimal, which is a repeated 6. That's why there's a line over the 6, because that will repeat in a calculator. And it is also represented as a percentage, which is 16 and 7/10%. Using the theoretical probability to predict how many times the spinner will land on Tomatodo in 300 spins, 1/6 is equal to x over 300. 6x equals 300. Excuse me, and they're using cross multiplication here. So 6 times x, 300 times 1. That's how we got this here. And then you have to divide by 6 on both sides to get the x by itself, and you get 300 divided by 6 equals the 50. So you can predict the spinner to land on Tomatodo approximately 50 times. Pilar performs an experiment where she spins the spinner twice. She repeats the experiment 50 times. Predict the number of repetitions of the experiment that will result in the spinner landing on a Toma section twice. Using theoretical probability to predict this, they have created now a chart of all of the possible outcomes. And so the theoretical probability of the spinner landing on a Toma space twice is 9 out of 36 times. So all this shaded in blue on this chart or organized list shows 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9 possible, and total is the 36, and then the decimal of that and the percentage of that. So use a theoretical probability to predict how many repetitions of the experiment will result in the spinner landing on a Toma section twice. I already said that. This is decimal, so now twice. So this is one time. Twice will be the 0.25 or 25 hundredths times 50, and that equals 12. So you can predict that the spinner will land on 2 Toma sections approximately 13 times, or 12 times, so I have to say 13.
Finn performs an experiment where he flips a coin 3 times. If he performs this experiment 100 times, how many repetitions of the experiment can he expect to result in the coin landing on the same side for all 3 flips? Finn performs an experiment where he flips a coin 3 times. If he performs this experiment 100 times, how many repetitions of the experiment can he expect to result in the coin landing on the same side for all 3 flips?
So the example showed us how to use a table and doing like cross multiplication. For this particular one, I'm going to show what example 1 talked about with using the tree diagram, and so that's what I'm going to show you how to do for this particular problem. So we start with our heads and tails as the first flip. Those are your options. Then you flip a second time, you can either get heads or tails. Then you flip a third time, you get heads or tails, but you have to do that for both options because it could go either way. And you do the same thing for tails. You have your tails or heads, then you have your tails or heads, tails or heads for the 3 flips. And so the total number of possible outcomes here is 1, 2, 3, 4, 5, 6, 7, 8. So our denominator for our probability will be 8 possible outcomes, and then our numerator for this probability would be only for the 3 times that we're flipping, we want to result in the same side. So that would only be if we were flipping here, if it landed on heads or it landed on tails. So there would be two possible outcomes out of the 8. And then we have divide 2 and 8, you will get 0.25, but it's out of 100, so you multiply by 100 and you would get 25. So 25 would be your final answer.